I'm not going to talk about that, right? So I was evasive. But Joe, you can like, you'll see, like I'm trying to not talk about Joe. No, come on, what do you know? So I mentioned it. Well, I've been talking to this inventor for about 7 years, and he's been developing these technologies using plasma, and it's frequency based, right? And at this point, I already knew that the thunderstorm generator, and I'll show you pictures of one now that's been retrofitted on a 300 kilowatt generator on a substation outside of London. And they're testing the damn thing. And it works. It does what it's predicted to do, right? Now, I knew at the time, this is February, a year ago last month, I knew that there was a whole series of testing coming up the next summer, which was last summer. And I was present at some of these tests and saw for myself what was happening and was able to, there with an admiral, a retired admiral from the Indian Navy, flew all the way over from India to be there present at this testing. That was at a major industrial laboratory at one of the research labs out in Raleigh, North Carolina. That's all at this point that I can say about it until the final test results are published. But I was there, saw it working, saw 2 generators, a control generator and one with the technology. I watched as the engineers and the scientists there calibrated them both. And then I was the one who went up and started both generators. They're in 2 separate rooms. Started the technology on one of the generators. And so we've got readouts. We've got gas analyzers there, probes going up into the exhausts of the generators. We've got a couple of guys there with mass spectrometers hooked up. So we've got multiple ways of determining what's coming out of the exhaust pipes of these 2 generators, right?
Yeah.
I go up there and I flip the switch on the one that has the thunderstorm, I'll call it the thunderstorm, the plasma generating retrofit to it. And we watch, so we got a first read. I can show you, actually, I got a printout of the readouts right here on my computer.
Really?
Yeah, I do. And you can see I think it's called a Kane 5 something because it measures 5 gases, carbon dioxide, carbon monoxide, nitrogen oxide, other methane, other hydrocarbons, probably like methane and whatever else, and oxygen. Okay, so flip the technology on. You can sit there, I can watch the mass spectrometer, I can watch the gas analyzer. You're looking at like 10% or parts per million. Let's see, carbon dioxide, carbon monoxide, and oxygen were in percentages. Methane and nitrogen oxide were in parts per million. So basically, oxygen is like at a 4 or 5% coming out of the exhaust, which is about typical for a generator like that. You got, I think, like 10, 11, was it 12% of CO2, CO, et cetera. So as you're watching it, here's what happens. The carbon dioxide, carbon monoxide, methane, hydrocarbons, and nitrogen oxides start going down. Oxygen starts coming up.
Interesting.
CO2 zeroes out. Carbon monoxide zeroes out. The nitrogen oxides go down to just a few parts per million, as does the other hydrocarbons. Oxygen tops out at over 20, I don't remember exactly, between 20 and 21%, which is optimum percentage of oxygen for pure unpolluted air. So what is now coming out of the generator, the generator with the technology, is pure unpolluted air.
No kidding.
No kidding. No
Whoa.
kidding. Yeah. And I've known, multiple people now that have seen it. The admiral, he took it back to India. India is seriously looking at it as a retrofit for their Navy.
Man.
The industrial, and I can show you this on the computer too. I've got photographs of like the big industrial scale application on the 300 kilowatt Perkins generator on the substation in London. I mean, they're testing it, and they may start retrofitting all of their because it doubles to triples the efficiency of these engines.
Wow.
Yeah.
Wow. And you think that they had this back in ancient times?
Some iteration of it, I suspect. And here, it just gets more bizarre as we go on. When you create these vortexes, you start this spiral motion inside the sphere, and then it travels down. So you got an outer cylinder and an inner cylinder. And one vortex is inside the outer, but outside the inner. Does that make sense?
Yeah.
Then the next vortex going in the opposite direction, and the opposite spin, is inside the next cylinder.
Okay.
Now, in order to transition from, and again, and I can show you this on here, because I got photographs of all the components, how they fit together, videos of them being assembled into machine shops, right here on this laptop, so you can see it. You can't, like if you have a sphere and you just cut a round hole in it, you stick a cylinder onto it, it's got this like sharp edge, and that would induce turbulence that would affect this coherent, organized vortex that forms. So you have to have a transition between the cylinder and the sphere to prevent that turbulence from being introduced. Experimentation has shown that one angle seems to be optimum for minimizing the introduction of the turbulence. What do you think that angle is?
I don't know.
51.84 degrees. Slope to base of Khufu's pyramid. Another coincidence? I don't know. But that leads me to think, okay, I've suspected all along that these pyramids and these structures are part of an ancient technological system. Probably somewhat along the lines of the principles of Nikola Tesla. right, who was able to generate energy by setting up some kind of a relationship between the Earth and the ionosphere. I don't know what's going on there. I'm still trying to figure out. Listen, I was in kindergarten 2 years ago. Now I'm in first grade. But when I was there at this testing, I'm seeing these scientists, physicists, and engineers stuff. They're all scratching their heads, going, "Okay, we see this," but they've been struggling for a year now to explain what is actually happening. There's a fellow by the name of Bob Greenyer, who I think has probably come as close as anybody. He's head of the Martin Fleischmann Memorial Project. Martin Fleischmann was one of the pioneers in these alternative energies, particularly working with plasma. Brilliant mind. He came on board about a year ago, and he was there was a Tesla Tech conference in last summer in Albuquerque, and my pal and partner in HowTube.com did the live streaming out to, I don't know, a couple of thousand people around the world that paid to be able to witness. And what they did in front of a live audience on a stage is they brought in a generator and retrofitted it right there. And as a result of that, several things happened. From there, it went to this research lab in North Carolina. From there, it went to a conference in Zurich where it was presented. Malcolm then went and spent 2 months in India demonstrating and building prototypes. And so, I mean, this is the phase where it's at now. Let's see, what else?
So they're really looking at this.
What?
People are really paying attention to this.
People are starting to pay attention to this. Yeah, that's exactly right. So there's a really interesting video that I would recommend watching. It's an interview with the gentleman is named George Lush. He works in high performance metals. He contracts, he's third generation. Their company, I think, was founded in 1951. He's contracts to the aerospace industry and NASA and all of this, these high performance alloys and stuff. And he did the annealing of this thunderstorm generator in England. And there's an interview, like